of papers from from various journals available. So it is something that you can check out online. I don't know if you have any questions on what we have done here. But just to explain that the reason why we actually secure the floor is that we don't really want any insect to interfere with the floor, because what you want is for you to be certain that the pollen that causes the fertilization is that which you would have introduced. And one way to kind of ensure that no other means of pollination would have taken place overnight would be to secure the unopened flower. So it's important to note that this flower that we pollinated this morning, when it was secured yesterday between 4 and 6, it was unopened. So of course no insect could have interfered before we secured it because it was closed. But of course the students would have observed, based on the instruction given, the plumpness of the flower, the unopened flower, and of course the color of the flower moving away from light green to a kind of bright yellow. And that fluffiness is as a result of the petals pushing against the calyx, which provided that security for the inner portion of the flower. Of course, the flower, you would notice, is both, it has both male and female, and the same flower, meaning here that it's monoecious, because both male and female is on the, but monoecious. But of course there are different types of monoecious plants. So but this particular one for cocoa is bisexual, because both are hermaphroditic, meaning that it's hermaphrodite in nature, because both sexes are born on the same flower. The other aspect of monoecious, meaning that you could have male on a separate flower and female on a separate flower, but on the same plant. And the next end of the spectrum would be the dioecious, where you have the male on one plant way over yonder, and then the female on another plant. Right. So these are some of the things that the students would have been exposed to in the course, and now they are here practicing it on the cocoa, because the flower is very small, and it's, for many persons, without practicing, it's difficult really to pollinate. But for example, in some countries, pollination has become commonplace, because it's really a method that some farms operators are using to increase their production and productivity by actually assisting whatever insects there are in the field that are actually contributing to the pollination. And given all the different problems that we're having within the cocoa ecosystem, exacerbated by climate change, then it's not difficult to see the reasons or the need why persons would actually want to go along the route of pollination. Interestingly, some results have shown where you could actually increase your production by up to 30% by doing pollination, and that 30% is 30% above what would normally be obtained from your regular natural pollination process. So a 30% gain is really, even though that's maximum, so it would have, maybe I would suspect it would range from anywhere between say 10 to 30%, but any value that you can add, and once it is done at an economical level, then of course it is welcome. So when you balance out what it takes, what it costs to do the pollination and the gains, that is the only time then you could make that determination that yes, this is something that I would want to practice in my space or in my system. right? So it may work in another country because they may have developed the technique to the point where they can see that added value, right? And so if persons are going to take on this kind of pollination exercise in their field, then the advice would be to develop a core competence team, a team that is competent, a core team of persons that is competent in doing this pollination exercise. So we're doing it here for breeding purpose, but of course, as was just being discussed, we can also do it for production purpose as well. So in that case, you would not necessarily have to cover, right? You would not necessarily have to cover as I do now, because all you're doing is just ensuring that pollination, effective pollination, takes place so that fertilization can be successful. You know, because fertilization, the cocoa plant behaves in a is very, very unique in the sense that if the flower doesn't get enough pollen, then what you may find is that even though the ovary may start developing, it may abort before it develops into the cheryl because there wasn't enough pollen to really send that signal that yes, the fruit has enough seeds in it. Or the developing ovary will have enough seeds to take the fruit to its mature stage. You know, so cocoa is like that. You know, so even though you may have pollination, it doesn't necessarily, and fertilization subsequently, it doesn't mean that the plant